Okay, this is purple problem number 2. So we have a tiger that leaps horizontally at 15 meters per second across a 20-meter wide gorge. The edge is level with the edge she's aiming for. We want to see if she's going to be able to reach it because she's able to reach 1.5 meters above where she lands. So the goal is to figure out if she can make it. So looking at our delta x, we're going to have on the x side, we've got a delta x of 20. We have a velocity in the x direction of 15 because it says that it's horizontally 15 meters per second. On the y side, we know that she is able to reach 1.5 meters, so I'm going to call that delta y able. So we want to see if she's able to actually get that value. So delta y able is 1.5. VOY, in this case, it's going to be 0 because it says that it's horizontally leapt, so that would be 15 meters per second. Normally in this type of situation, it seems like it should be a value, but this is kind of a tricky problem. Gravity is our problem that we also are going to have. We know that information. We find a y we could look for in the time in the x direction. So as far as our diagram goes, we're going to have a cliff or a gorge, so we're going to have two different things. We're going to have one side, so velocity is 15, it's leaping horizontally. So what's going to happen? Gravity's naturally going to take over, so she's going to fall, which essentially means that she's definitely not going to land on level. So we're trying to figure out how far she's going to fall in that 20 meters of space. And ultimately, the goal here is to see if delta y of the fall is less than the delta y she's able to climb. So if the delta y able is greater than that value, that means that she's totally able to haul herself up on the other side. But if the fall is greater, then she's not going to make it. So to find this, we need to figure out how much time it takes to travel that 20 meters. So we use our delta x equation, which is delta x is vxt, so 20 is 15t. Solving for time, we get that our time is 1.33 meters per second. So we can reduce that down to 4/3. So in that situation, she's going to be moving forward to get to the other side and falling. So time x and time y are both 1.33. So from that information, we need to figure out how far down she's going to fall in that 1.33 seconds. So we're going to use the free fall equation again here because the v initial y is 0. So delta y of the fall is 1/2 gt squared. So we need to figure out what that delta y is. So 1/2 times the negative 9.81 multiplied by 1.33 squared. And that's going to give us the value of how far she's going to fall in that time. So just by the numbers, you can definitely tell it's going to be larger than 1.5 anyway, but the actual value is 8.72 meters. So that means during that 1.33 seconds, she is falling a total of 8.72 meters, which is well above the able height that she can reach of 1.5 meters. So she is not going to clear it. She's not going to make the actual jump. So as far as justification goes, the work above is enough to show that she's not going to make it because the fall is greater than the ability she has to reach.